program. Okay, writing the program is more important since we are computer science department. Okay, so how it is implemented is more important, and I told you that you better, if you have a laptop, better bring it here. And did you download my source code? Did you download my source code? My source code contains 4 files. Okay, one is the README. Okay, you can try in your home following the README, or try it together with me now. I have a makefile already given to you. How to compile. This code, I didn't test it on Solaris. That means I didn't test it as Unix. Whether Unix will be capable of doing the same job, I didn't test. I only tested on Linux and Mac. Okay, they both work. And the code itself is a little bit long. So what is the meaning of different? First of all, look at here. Okay, I think this is the first time you see so many header files. Okay, yeah, you play around with the operating system course program. The operating system program only around 5 header. Now there's a bunch of header, 9, 10 up to. Okay, so this is what we need is later on I will describe which type we read something, which type we do something. Then we have the main. Okay, basically if it is a server, so what is the meaning of a server? Will server suddenly die? Usually no. Okay, server is usually a guy stand there, don't leave. Okay, you just stand there, wait for a connection. After server connection, wait for another connection, and go indefinitely. So that you should expect that inside the main, you will have a main loop, and the main loop usually is a while loop. Okay, it's usually a while loop for server. Now for client, usually client is one-off. One-off means that I send the things to the server, receive the service, or receive the materials or data, then I stop the connections. So in a client, the design of the client usually is just a main and then set up something. You don't know what I've set up. Later I will tell you. I will tell you. After I set up something, I fire up things without using loop. You can see this. I never use loop. Okay. So just send something and then time to shut up. Okay. Close some of the file descriptor, and after receive receive data, then I will return 0. Close the program. Okay. So you can see some basic difference, and now I tell you about first according to the books. Okay, well you already know that we will talk about the TCP/IP stack. Okay, some of the extra things that I want to tell you is that not nowadays. I heard about this term since 2006. Okay, and this guy called TOE. What is the meaning of TOE? Basically, it's like this. You know, application. You put all the logic of an application. You write a web server. So all the logic of web server is packaged as a program and create a process and run it. Now, how about the TCP, the network layer that is IP? Okay, all are inside the kernel codes. Okay, some people think of one way. Okay. I don't know if you believe it or not. I also don't believe it. But once I read some data log, some documentation, I start to believe it. The thing is, if I have a server, okay, I don't know why, it's plugged in several network card, and each network card is a 1 gigabit per second speed of, the highest speed is 1 gigabit per second, and they boost it really up to 1 gigabit per second. Then inside this computer, what will happen? So you will spend some of the time, the packets comes in. I don't have a laser yet, that's the big problem. So data come in, so go to the physical layer, go to data link layer, pass to network, pass to transport, and eventually reach your application. Now that means that your application will be driven into a crazy mode, right? You have 1 gigabit per second on this network card, another gigabit per second, another network card. So the application kind of driving into a crazy mode, running many things. But don't forget that you have a friend called kernel. Kernel also as busy as you. So what is the conclusion? The conclusion is they claim that the manufacturer of some server claim that 50% of the CPU load go to the kernel. 50% of the CPU load go to the application. So that means that you buy a CPU. if the server is so busy that you receive very, very frequent traffic, half of the power actually goes to kernel side. Half of the power goes to the application side. So those hardware vendors think of one way, very clever way. To move the source code of kernel offload to another card. Understand what I mean? So let's imagine that, although it's not happening, let's say you have a GPU card. How about I put the kernel handling of the networking into a GPU? Wow, then you will think that, oh, this should be crazy, but maybe work. And if it's work, it will offload all the things from the CPU to that dedicated network card. And that network card is called TOE card. Okay? But I don't know why. Linus, the creator of Linux, okay, reject this idea. He hates this idea. Okay? And don't allow Linux to have TOE card support. Okay? Or their maintainer. Okay? May not be Linus' decision, but the maintainer of the Linux kernel think that it's not a good way to offload all the code from the kernel to a network card. So contradicting, only Windows Server support this card. Okay? So Windows seldom sucks in this high-speed network. Okay? Your high-speed network, plug in the TOE card. You can already search for it, TOE card. Search how costly it is. Very expensive. Okay? Because it's just to save one half of your CPU loading into a hardware card. So there's some extra things. And now, what I'm going to tell you is system call level things. I am a process. I want to make connections. I need system call in order to help me. And what are the system calls that we need? Basically, the system call is just like opening a file, right? You want to have a file content, you want to read the file content, you ask for the hard disk service, you don't need to know there is hard disk, right? You just use fopen, or you just open. Then you eventually be served with that associated file. Now, how about network? Network is the same. You tell the system that I want to open a connection. Let's say the connection is an IP address. I don't know why. There's an IP address called 123.123.123.123. Okay, every year I use this example. And every year some student will be so clever that, oh, let me look it up. Ah, it's in Beijing. Okay. I just think of a random place, okay? Some people will take it up and tell me, oh, it is there. Okay, don't mention the IP address. Okay. So 123.123.123. Okay, let's say it's like this. So do you need to know where is that location? You don't need to know. Kernel will help you once you call the system call. Okay? Do you think that that IP address should go to, let's say, my MacBook Air? MacBook Air, at least I have how many? I have 2 USB ports, 1 Thunderbolt port, also 1 Bluetooth interface. So each USB port can become a network card, right? I can plug in a network card, a USB network card there. I can also plug in a Thunderbolt, 1 GB Ethernet plug. Also, Bluetooth also considered as a network. So at least I have Wi-Fi 5 network connections. The kernel will design for you which connection, which hardware it will use. This is none of your business. Now, if you know about this, then what will be the answer that the kernel will serve you? The kernel serve you, okay, just telling you that there is a thing called socket. Okay, you tell me the IP address, you tell me the port that you want to connect, then I will return you a socket. A socket point to something. What is the point to something? Point to some data structure. Okay, we call it data structure or code. Okay, because data structure work with code, or the code work for the data structure. Okay, for TCP control and for the UDP control. So UDP is a reliable control. TCP is a reliable control. So the socket will eventually point to that control code. Okay. And that's why sometimes we call it network programming is called socket programming. It's just a name. And it's so what happened? It so happened that this socket is actually a file descriptor. Okay? So your nightmare comes back. Okay? When you're doing OS assignment 2, always play with file descriptor. Now it's a peer. Okay? You open a socket, and how the system code level, map this socket to you, to your process, using a file descriptor. Okay, so this is the file descriptor. Now, with the file descriptor, then what can you work over the file descriptor? Okay, I don't know whether you still remember the pipe. Okay, what is the pipe? Pipe is always one way, right? From the left to the right. But how about socket? Socket, once you open it, it is a dual pipe, two-way or duplex communication channel. Okay, so you have a web browser, web service, and you can read over that socket. You can also write over that socket. Okay, so this is a dual direction. And yeah, I have mentioned this just for your revision. Okay, so how to make a connection between something that you already know. You already know file descriptor. Okay, but how can I map the file descriptor to a socket? Let's say now let's recall some of the things about file descriptor. A file descriptor, how can you open it? Still remember? No one remember, I know. Okay. Main system call open. Okay, remember then with the open, you mention the path name, you mention the opening mode, or I would call it flag. That mode is not opening mode. Okay, that mode is I would say that's called a permission. Okay, after you create a file. So the opening flags, as well as the file path, then you can open a file locally in your hard disk. So what are the flags? The flags may be a read, write, append mode. I don't know which kind of mode you are using, as well as the location. So what is the location that you want to open? Now, if it is become a socket, then the socket only requires to give similar things, but in different names. It wants to know your mode. You want reliable transfer or unreliable transfer. Okay? And now this is not a path name. I don't want a path name, but I want an IP address, your target IP address. And when you connect to a machine, we seldom really connect to a machine. We connect to a service provided by that machine. So together, our machine usually have multiple servers, and each service binds to a port number. Okay? So you will be required to ask for the IP address as well as the port number. Okay? So to illustrate, I usually will write in this way. Okay, I will write in this way. So there is a socket of a process. So I kind of draw it in an overlap manner. Okay, so this is a machine. A machine has an IP, and inside that machine we have a client. I don't know whether it's a browser or not. There's a process, and the process you open a socket. And the sockets eventually bind to a port number to represent that there is a service bind to it. Okay, for the server, it's just the same case. Okay, just the same case. I live in a machine, so I have an IP address here, and this is the process. But the process is not you cannot talk to the process directly, but talk to the port number that this service is binding to. Okay? So to illustrate it is for the client server model is become something like this. The server, this is a server, has a port number, okay, bind to a service. So how to check whether your machines has service binding to whatever port? I will use the terminal to show you. Okay. Now, in case that you have a Mac machines, okay, you can also do this. If you don't have a Mac machines, you can SSH to department any kind of a Linux machine. Okay. So ready? No one has responded. Okay. So there is a command called netstat. So it's network related statistic. Okay. So it's a minus C. I can't remember the parameter. Let me check whether it's minus C. Okay. Oh, this is not minus C. It's minus P, right? Minus P. Oops. What? Okay. I don't use Mac anymore. I use Linux. Okay. That's that. Minus A. Minus C. Said, no. Wait. Stop. Come on, ting. Okay. Yeah, it in Chinese. What? 信我，大家講信字 P minus P, okay. You have to believe in me, okay. So what I'm going to type, okay, is let me put it down there. So a set of parameters. So what are they? Minus n. I need minus n. Why? Minus n means don't call DNS lookup. Don't look up for the true name. Okay, so it will speed up the report. Okay, the report don't need to do a lookup of the name. Minus T, look for TCP. Minus P will show you that service bind to which program, which process. Okay, so then we can know that this process whether it's open a network connection or not. Okay, of course find less because I know that there will be many connections inside my machines. So let's go. Are you ready? Go. Okay. Wow, there you go. What is that? It's my machines. Okay, my machine IP address is this. Okay, talking to what is this machine? Huh? I know. This should be our proxy server, department proxy server, port 8000. Okay, but why this guy talk to the proxy silently? Huh? Stealing data? Okay, I don't know. But the program is this guy. Okay, so let's check. Again, I have a Dropbox. Very mysterious. Dropbox, can you see this? Dropbox, this is my machines. Silently talk to another machines. Okay, and this is my Mac Mini. Okay, silently talk to my Mac Mini using another port. Okay, maybe they are doing Dropbox has a control called LAN discovery. It discovers whether in the same LAN has another machine signed up with my account. Okay, it will discover, and it's called LAN discovery. Maybe they go through LAN discovery and find, oh, there is a browser there. Let's connect to it. Okay. Yeah, Dropbox is naughty, huh? So how about this? SSH. I use SSH to connect to what is this machine? What is this machine? Let me do an NSLOP. NSLOP is to look up the domain name. Oh, Linux free. Okay. I have a connection with Linux free. This is okay. So how about others? Any mysterious connection? Dropbox again is you. Okay, Dropbox. What are you talking about? It's talking to. Oh, again, it's my machine. Okay, it's so and so forth. So you can see as many services is binding to some. Silently talking to foreigners. Okay, and so forth. I guess this should be our proxy server. Let's check. NS lookup. Wow, 有冇咁多個名啊? Oh yeah, should be our proxy server. Okay, so it's silently talk to the proxy server. Unity. Oh, I'm running Linux, so it's Unity. Okay, so let's jump ahead. Okay, no much servers left. So this is my Linux. So how about the machine that you're looking at? Did you look into our department machine? Don't dare to do so. Okay. You know, I'm always the naughty guy. Let's look at Linux 17. Okay. Any people running job? Oh, who is this guy? Okay, don't care. I become copy and paste that guy names. Next that minus all servers now. I don't list TCP only. Don't look up name. So process. Quite less. Oh, this time we can see another report. No, nothing. Not funny at all. Nothing. Okay. So my machine is more funny. Okay, so you can see this. You can check multiple processes. A process can have multiple connections. And in this example, I will illustrate it using a client server model. The server has a port. Usually we will call it server port. Later on I will tell you how to differentiate a port as a server port or a client port. Later on, because of the core, okay, because of the system call you use, it's become different kind of port. So this server port take a very interesting job. The job is to welcome people. So this guy wants you to take a connection to this guy, and also this guy, I don't know why, do the same connections but with a different port number. So how can it be possible? How can it be possible? Maybe this machine create two processes. Okay, the same program. The program connect to this machine, but launch another same program under the same machines. Then you will find another port, bind to the machine, and try to connect to this server. Okay, and how about the server? Well, the server, when it's find, oh, there are two connections. Okay, so I spawn another port so that I can serve the next connection. Okay, under the TCP/IP design, we don't need to. Okay, well, we'll do one thing later in this course. I will talk about a concept called demultiplexing. You send traffic in. The traffic carries something, carry the source. I depends on the source. What is your source port? Then I will know who you are. Okay, so then here I don't need to spawn a new socket in order to serve the new connections. And the big picture is something like this. Okay, some process may spawn multiple connections to the same server. Some is only one. Okay, now how about peer-to-peer? Peer-to-peer is more horrible. Okay, if you know that I need port numbers. Okay, I need sockets in order to do a connections. Then if it is a peer-to-peer model, horrible. How horrible it is. Now let's look at this figure. The port number with a red border, I will call it a server port. A port that will welcome connection. Okay? So if it is peer-to-peer scenario, that means that every machine needs to welcome other connections to come. So every machine has a red port, red color port, to welcome others people. But you cannot just use this welcome port, okay, or server port to send out data. Okay, this is a networking 101. Remember this. The server port is there. We call it in a server mode or listen mode. Listen to incoming signal. I cannot use the same port number to send data out. Okay, so in a peer-to-peer model, this guy, okay, is a very good illustration that say this guy open a listening port, server port to serve others, but at the same time, because this guy wants to download files from all three peers, so it has to create new ports in order to connect to this guy's red port, this guy's red port, and this guy's red port. Okay, so this is how we set up different communications. Remember this. This will be, although it is doing an FTP service, okay, but remember this is 101 that you have to remember. For a client to connect, you need a new port. But if you also welcome connections, you have to open a listening port. Now, how about the programming? Wow. That's why I look at the watch. Do I have enough time? Okay, now stay awake now. It's something important. How to write a client. Okay, I said that before I start the lecture. I said that for a client, no need for a while loop because usually for simplest client, you connect to the machines and let's say send something, and wait for something, and then done. Quit the program. So you can see that there is only one path, starting from the construction of the socket. That means open. I want to open a connection between the process to the kernel now, okay? And tell the kernel that, oh, I opened this guy, this socket because I want to connect to, let's say, Dr. T.Y.'s phone computer. I want to hack him, okay? Then after you have opened a socket, there is an optional part. So I give a star here. What happened here? Why I okay, undo. Undo. Mac sucks. Undo. Undo. I forget about it. What? I suddenly out of control. Okay. I also yeah. So here is asterisk. It means for the client side, the bind port action is not necessary. It is only optional. Some people love to bind port. Let's say, oh, I want a client port to bind to a specific number. Go ahead. But usually the client port needs only a port. Whatever numbers is just up to the kernel. The kernel gives you a random port number. Okay. And what's next? Next is the connect. After you bind to a port or not, whether you love to have a random port number or not, it's up to you. Then everything is ready. What are everything is ready? Look back to the previous slides. I have the port number, this guy. I have a pin guy, the socket. Then it is ready to connect. So there is a system call called connect. There really a connect system call. And this connect system call is a blocking system call. So what is the meaning of blocking system call? It really make connection now. So the connection can fail because I don't know why that server is shut down, okay? Or this server is not shut down, but the service is not on. Let's say I didn't turn on the web server, but my machine is working, okay? Then I cannot connect to it. Then I have to wait for timeout. Or I can successfully connect to it. So you have to look at the return value of the connect system call, and it is a blocking system call. And after you successfully connect, then what can you do? You will be notified that connect successful, and you can use the socket file descriptor. Yeah, what is the use of file descriptor? Read and write. Okay, you can use read-write system call now. What is read system call? Read from the network. What is the write system call? Send out things to the network. Okay, so read-write system call now become powerful. Previously, read-write system call, according to what we know from the operating system calls, is read-write from a file. Now it's not read-write from a file, but send data using the write system call, receive data using the read system call. Okay, so this is a side notes I put in here. And now I don't want to play anymore. I want to close this connection. No problem, close it. Okay, just use the close system call. Now, can you find this execution flow in my example code? Let's see. Client. Look at the main test function. I have main test function here. In a line 21, you find the socket creation. Okay, although you don't know what it is. Okay, I can explain to you. It means that it is how can I explain to you? I want to have a family, okay? I join a family, the networking family, the internet family. And sock stream means TCP, okay? So that's why I say that create a socket, which is TCP socket. Then if it fails, it will return -1. And then something bad happened, okay? You are welcome to do a copy and paste, okay? Oops. Why I didn't fix this bug? Okay, if you know MEM set, you know I'm doing wrong. Should be this. Okay, yeah. I don't know why. Okay, so then what else? There's a bunch of codes for you to set up the IP address. This line is to set up the IP address. This line is to set up the port number. Okay, so you're welcome to copy, but with that modification. After that, you can call system call connect, okay, with the checking whether the connection is successful or not. If it's failed, it will return -1, okay. Then after that, I can use read-write system call. You can see I have a write system call, and then close the file descriptor, and then stop the game. So you can find this execution flow in my client program. Now, how about server? Server is hard to explain. Okay. Server, first of all, we have the socket. I also need to create a socket, right? Because I'm a server that you talk to kernel. Okay? And when I create a socket, I need to bind to a port now because the port number is actually like I'm inside the building, I'm inside SHB. You want to find me, okay? You are not walking in your SHP and shout, where is TY Wong? Okay, TY is here. Okay, this room is not TY Wong. Okay, but I'm not in this room. Okay, I'm in a SHP125. So SHP125 is my port number. Okay, so then I have to tell to the port pick that what is my port number, and I expect that. Okay, I don't need to change my office. So I will say that this is my port number. I bind to it. I will never leave this port number. So that's why I label here the bind is no longer optional. Then you will enter the mode called listen. So that means what? That means whenever you have a port, create a port. Then inside the program, you call listen. That means you are a server. You enter listen mode. Okay, you listen to the new connections. And what happens next? You will start to accept incoming call. Okay. After you accept incoming call, you will enter a blocking mode. It is a blocking system call. Okay. It will block until a new connections come in. And after the new connection come in, you can call read and write. Okay, and start to serve other body. Okay. So I will skip ahead one page later on. This page I must come back. Okay, but I want you to look at the big picture. So what is the big picture? Actually, I need a laser. Why this laser sucks? Okay. Yeah. Forget about this. I don't have a laser. Do I have a pen? Good. Okay. So for the server flow, I cannot complicate it. For the server flow and the client flow is all start with socket and then bind. Now what's next? Next is if you are a client, you will call connect. Okay. I don't have laser. Okay. Yeah, this is laser. And you call connect. Listen. Can I flow like listen? Yeah, it's too high for me. Okay. I mean, 氣勢嚟㗎嘛, okay. So that's connect. And after I call connect, that means I have a client. Now, if I have a server, you will see the execution path difference. Okay. It's all listen. Now, how to match the system call? Basically, this connect match to accept. Accept is blocking system call. Connect is also a blocking system call. So that means that accept means I stand here, accept you to give me a punch. Okay? And connect is I send you a punch. Okay? So they are a pair. One is standing there, one is, oh, come on. Okay? So this is punch you. Now, that means these two guys stand there. When you find that, okay, accept guy, find that, okay, the connect signal coming, I accept you. Then you both will enter another level. What is that another level? It's application logic. All happens in the yellow box and none of the business about the application logic. No application logic there. Can you see the application logic? Do I define this as a web server or app server? I never define anything. The application logic is in the ping port. Okay? So then the ping port will exchange data using read-write system call. Okay? They do read, they do write, okay? And after some time, this guy don't want to play anymore. This guy will go close. This guy will go close and then exit the program. Okay? So this is the big picture. That's why I say that I need to skip ahead. But what is this? Why is the secret I want to skip ahead? Because the accept system call is hard to say. What is it? The accept system call is something that is very crazy. You need to write some program before you understand this. Okay? So now that's why I asked you to bring the laptop. We will go to read some code. The server code. Okay? The server code, look at here. The server code, I said that we have a main loop to loop. Okay, what is the loop? Let's check. The loop, this is the line 1, okay, the line 1 is nothing, it's a comment. And the line 2 of the loop, see, the loop is to accept new connections. I said that the accept connection is a blocking system call, right? So that means I will stand here, waiting for you, and serve you for a while. After I finish serving you, I will look back to the head and accept the new system and new connections. So if you don't believe in me, okay, I can do something. Where is okay, these two guys. These two guys ready. Let me do a small change. Server. Server.c. Oh, what? This is my new machine, okay. Let me 型少少用 VIM 添. Okay. So I put a printf here before accept. Okay. So I stay here before accept. Okay. And also say that after accept. Okay. So let's see what will happen. Change the code. Change the MEM set. Why is there is a bug here? Okay. Also change the MEM set. Yeah. Also same bug. Okay, MEM set. No, good. Make. Okay, so the server need a port. Okay, I can read from the command. Let's say my port number is not always 1, 2, 3, 4, 5, 2, 4, 6, 8, 0. Okay, this is a server port. So you can see there's the program executes and go to before accept, then call accept, stand there. Okay. Now how about the client? The client code. Okay. So where is this client code? The client is in the same machines. Can you see this? This is the same machine, same machines. So then I use a client. Okay, it's asked for IP address. Okay, so usually we will use this. How many of you don't know this IP address? Raise up your hand. I know maybe some people don't know. This is called localhost. Okay, this localhost IP address. So talk to the localhost, and I just bind to a port called 246X0. So copy and paste here. Oh, sorry. Yeah, business client. Go. Okay. So once I talk to that guy immediately print after accept. So it sends your connections. Okay, but there is nothing about the application logic. Okay, it just sends your connections. So what happened inside the server? Why the server don't print the next line? Let's see. Inside the server, basically, the server is reading. Okay, it's called a read system call. Reading, what is the meaning of reading? Now, reading is not read from a file, but read from a network. So it's waiting for data. Okay, so waiting for data. What is the data that is being sent out? So let's take a look at the client. Okay, the client basically will do two things. I want to demonstrate two things to you. One is to send nothing. I don't send anything to the network and then quit the program. Or I choose to send 4 bytes. Okay, and I hard code that 4 byte. What is that 4 byte I want to hard code? I hard code this 0x1, 2, 3, 4, 5, 6, 7, 8. Okay, and then send this 4 bytes to the network. Now, I go back to the program. So first, I want to demonstrate sending something. So how to send something? I will use the write system call. Yeah, write. Very hard to use the mouse Y. Okay, so this is write system call. Okay, let's go. Yeah, it's 2. Send. Okay, then here we'll receive the results. We receive results because the application logic we understand because I write both programs. I know that after this guy sends 4 bytes, the client will go away. The client will go away. So I would decide to loop back to the accept call and wait for the next communication. Okay. So how many of you is in our department network now? You can try it now. Let's say you are inside the department network. Okay, and you can talk to me using the /client, but with this IP address. What is the IP address? This one. And the port number is, okay? So if you're in department network, you can talk to me. And later we will see some exchange here. Okay? So I will just put in a hole here. Put a hole here, and you are not going to crash my program because my program do nothing. Okay, so you're welcome to crash my program. Okay, can anybody connect to me or trying? Are you still trying? If you're in department network, you can talk to me. If you're not in department network, you cannot talk to me. It's okay? So I just put it here for a while. Now, I need to talk to you about another control, and the control is about the accept system call. Okay? The accept system call has something strange. So what is the strange thing is about? During you call the accept system call, okay, basically you are using the descriptor, file descriptor, return from the socket. The socket gives you a file descriptor. Okay. Now after the accept system call, basically the accept system call wants to create a new controller, a new control handler, okay, for you, because the accept system call may be calling multiple times to represent multiple connections. So how can we represent multiple connections? There is a clever way that the engineer designed this kind of API is very powerful. They're extremely clever. They design to do something. After you finish calling the accept system call will return what we call it. Well, why is like this? Return an accept file descriptor. And that file descriptor is different from the socket file descriptor. And that accept FD represents the new connections. Okay? So that means what? That means I don't need to use the same socket FD over and over again. The socket FD is for listening. Listen and accept. After accept, I use a new file descriptor to represent new connections. So if that's the case, the server programming can become very colorful. So what's a colorful implementation? It's something that you want to avoid. Fork system call, pre-thread create. How to use it? Very interesting. After you listen, then you call accept, right? And accept can produce a new file descriptor to you to represent the handle of the new connections. That means that after I call the accept system call, I already accept that connection and I have a handle. I pass the handle to the new thread. And let the new thread to handle that connections in parallel with the accept system call, so that the accept system call can wait for another new connection. Understand what I mean? So that means that I can have a thread forever looping the accept system call, and within that thread will create another thread, and that other thread will only handle application logic. Okay? So this is an extremely powerful way to parallelize your thing, and this is a very typical way to write server. Okay? But depends on whether you want to do a fork, okay, or doing a prefix create. They have pros and cons. Fork, of course, will be cleaner because you create a new address, new process, copy all the address, so that if your application layer code goes a segmentation fault, it will kill the accept thread. But if it is inside the same, using the same thread, using the same process but under different thread, one of the thread gets segmentation fault, whole family dead. Okay. So that is pros and cons. Okay. So later, I guess for you guys, you need me to write a example code. Okay. You will get lost a bit. I didn't give you code so that you don't know what I'm doing. Okay. So maybe next time I also give you the code using fork, how to implement a parallelized server. Okay. So boring, huh? Usually talking about code is not exciting because well, not this. Because this kind of thing involves many things like this guy. What is this called? Later on in the tutorial, our tutor will talk to you. What is this kind of call? And in the tutorial, basically tutorial will try to explain every pieces of parameters. Let's say the connect system call. The connect system call has so many parameters. What are they? the tutorial will explain to you what are the parameters. Okay, so that while although you're doing a copy and paste from my code, you still understand what it means. Okay? Any question you want to ask? Any questions? Any question you want to ask? If no, then next time I will give you a parallel server using fork. Okay, so that you can accept one and then fork and process and then finish all the things and then it will kill itself. Okay, but while you have another process, the accept process is still there. Okay, so any people talking to me? Wow. Oh, thank you. Some people already changed the code and sent me different values. After accept, who? Who is doing? Oh, nothing. Thank you. Okay. Wow. Hi.
佢要 send 翻 message 俾你，你先可以繼續再 send 佢咁去派佢。
Because my server is stupid. Okay. After I accept, I will only call wait once, and then terminate you. Okay. So then you cannot use a while loop and crazily send me things. I need to change it. Yeah. Use your connects. Also put the connect inside a while loop. Yeah. But I mean, that's not as powerful as if I change a server and endlessly waiting for your connections. Okay, wow, wow, in client need to start the while loop from start from the connect and then again connect again. I didn't close it. Okay, it's still here. Yeah, only 23 guys try out. Okay, wow, what happened? Okay, so that's it. Welcome to download my code and do the change. Like the guys here happily changing their code and talk to my service. Okay, I will close it now. Finish all the playing. No. What you're going to do? Save idea. First of all, I stopped the recording. Okay, there's no need to.